The dairy sector is one of the largest water and energy consumers in Europe. The consumption is about 6.5 megawatt hours of energy and 2 cubic meters of water per ton of processed milk. 98% of the used water has drinking water quality. More than 70% of the wastewater and 90% of the energy consumption along the entire milk production chain are generated at the dairy processing plant.
We wanted to improve the situation. For this reason, we look more closely at average dairy process operations and focus on 2 typical products for our case studies. Our goal is to demonstrate that we can reduce at least 20% of energy consumption and 30% of water consumption when selected process operations are improved or replaced by new technologies.
Scientists and specialists from partner organizations started gathering data to identify initial consumption patterns of water and energy in the selected case studies. Baseline scenarios of mozzarella and dried skim milk production processes were developed. A software-based tool was developed for data analysis and visualization of the whole production process and unit operations. Process scenarios were compared and different possibilities evaluated and pre-selected according to their potential to save water and energy. A technology toolbox comprising alternative innovative technologies was used. As a result, the technology screening process, 6 technologies were chosen for further development. Selective protein recovery by means of electromembrane filtration. Efficient wastewater treatment. Water-saving cheese production. Oxygen-free drying by means of superheated steam. Fast heating by means of microwaves. And cold pasteurization.
This method, also known as pressure change technology, has been developed up to a pre-industrial stage at Fraunhofer IGB. This technology is a promising alternative to the thermal or chemical preservation of beverages because it maintains the nutritional properties, taste, and color of the products, eliminates vegetative bacteria at low temperatures, and requires 40% less energy input than conventional thermal pasteurization.
During this process, an inert gas like nitrogen or argon is pressurized and mixed with the liquid food. The gas diffuses through the cell membranes until equilibrium conditions are reached. When the pressure is abruptly released, the gas returns to its original gaseous state, expanding and causing microbial cells to burst.
Microwave heating has several advantages. Due to volumetric liquid heating, pipes do not overheat and fouling is avoided. Heat transfer and performance of the equipment remains constant and shutdown times for cleaning are minimized. Thus, production runs are longer. This represents an overall saving of time, energy, and water. Moreover, steam heat exchangers can be replaced by electricity, which can be provided by any primary or renewable energy source. The process is especially recommended for high solid and viscous products.
This process uses superheated steam instead of hot air for spray drying. And in superheated steam spray drying, we can recover the latent heat of evaporation. This can then be used for pre-concentration, for example, which will save around 30% of energy. Advantage of this process is that we have an oxygen-free atmosphere, and therefore we have a benefit for the workplace safety and also for product quality.
Mozzarella is produced by stretching and kneading of cheese curd. Our single screw extruder was designed to save water and energy during this continuous process step. The high water consumption of traditional mozzarella production is reduced by nearly 90%. Keeping the product quality the same, less wastewater has to be recycled and heated.
Together with the company EUT, we developed a concept to recycle process effluents. With the electro-oxidation process, mozzarella cooling water containing organic residues with the concentration in the range of 300 mg per liter of COD can be converted into process water. This effluent accounts for 80% of the water consumed in mozzarella manufacturing.
Electromembrane filtration is a technique designed to separate molecules by size and charge. This can be achieved by superimposing an electric field to a standard membrane filtration cell.
With this technology, specific high-value proteins and peptides can be recovered from mozzarella process effluents. The enriched fraction can be used for applications in niche markets like sport nutrition, adding value and increasing benefits to mozzarella manufacturers.
During this project, some of these technologies were tested and applied in the dairy industry.
My company, EnReMilk, can confirm the benefits of the studies conducted during the project. For example, we installed a microwave heating unit at our factory and evaluate not only the performance of the new equipment, but also its influence to the whole spray drying process. Significantly, we minimized or eliminate fouling, reducing shutdown times and cleaning efforts, and increased drying yield by at least 11%. We expect that the implementation of other technologies will bring even more water and energy savings and will significantly increase the efficiency of our whole production.
EnReMilk has shown that prior to the implementation of new technologies in an established system, economic and environmental impacts can be modeled and estimated accurately. The developed tools can give manufacturers an overview of how a new technology affects their entire plant in terms of climate change impacts and water use, and several other environmental indicators.
One of the major aims of the EU is to support technological innovation. During this project, we were able to assess not only economic benefits for technology adopters and technology developers, but also new opportunities for the technology suppliers.
The social impact includes the risk to adopt new technologies at various levels. We developed indicators for employment practices, health and safety at work, legislation compliance, consumer choice and value chain actors. We have also investigated which policies could enhance the adoption of such eco-friendly technologies.
This project is very ambitious. It requires a multidisciplinary team with a profound knowledge in various technical, scientific, environmental and social aspects. Because of this, we were able to deliver an integrated approach that demonstrated that water and energy savings up to 30% can be achieved. Most importantly, we established a methodology to predict the overall impact of adopting new technologies that can be replicated in many other studies in the future.